Asaf and I are really excited to be here today. And today, of course, we'll be talking about the fun and exciting world of software supply chain. So without further ado, since we do have a long period of time ahead of us, we have an hour and a half, and thank you guys, everyone, for joining us. We're going to try to make this as fun and comprehensive as possible. So let's just get off and start going into it. So let's get going. Asaf?
So thank you very much for attending. We have, I would say, a packed agenda when we try to split the different topics into different areas. So pretty much the agenda is to start with the attacker point of view, about the mindset of the attacker. Why would an attacker utilize such supply chain attack? What are the common attacks, the recent one that we see recently about implementing such an attack, and how much does it cost? And then we're going to look at the defense point of view. What are let's say the recent regulations and also recent approaches for defense against such type of attacks? And then we're going to after the break going to look at the practical points on how can you implement security in order to make sure that you have secure builds and essentially protect yourself against those type of attacks.
And as stated, I'm Bill Manning. I'm one of the solution architects here. Been with JFrog just about 5 years now. Watched the company grow from being a small little scrappy bunch of guys all the way up to what we are now, a public company. And very recently we had our acquisition of Vdoo, and we have the wonderful Asaf here with us. And very happy to have him be part of the company, and I'm honored to have him here to talking today. And Asaf, if you want to introduce yourself.
Sure. So my name is Asaf Cohen. Been in the security industry for the past 20 years. Doing mostly, I would say, both offensive and defense, like offensive simulations, such as penetration testing and ethical hacking, as well as doing defense work in order to protect organizations against those type of attacks. So always a white hat hacker, by the way. And I'm part of now JFrog, but beforehand I've been at Vdoo. Vdoo established security product to do automatic security testing of binaries. And now with the acquisition as part of JFrog, we in the process of integrating the product into be part of the platform. So stay tuned for more things in the JFrog platform. So let's start with...
I was considering myself a gray hacker myself, by the way, just so you know. So. All right.
If you can go to the next slide, I think we would like to start with the security orientation or the security mindset about how does attacks occur. What is the, I would say, small history about it. What is the essence of essentially having software supply chain attacks? And just as a disclaimer, the type of attacks that you see here are essentially software supply chain attacks. There are also hardware-based attacks, which are out of the scope of this session. But when it comes to software supply chain attacks, when you look at the essence of those supply chain attacks, essentially a way for an attacker to slip malicious code into the target software. It can be either a malicious component or it can be altering the software, but somehow abuse the way that the software is being built along the way, and so the outcome would be that you eventually have a malicious piece of software integrated into a trusted software. So you see that the history of supply chain attacks is, even though this topic is relatively, I would say, new to the community, we see attacks that were conducted many years before, such as the Stuxnet and Target and other things. I think the most common ones, or I would say the one that got the most publicity, is the SolarWinds attack that was conducted last year. That really was unique in its novel way and the amount of target networks that it affected. But essentially, if you look at the origin of all the things that is common to all of this type of attacks, you would eventually get to the fact that someone along the way was able to compromise or inject malicious code in a way that it would be at the end build, and someone would eventually, the consumer of the software would trust this piece of software that was contained with malicious code without knowing that it has been malicious. Bill, maybe you can go to the next slide and I can explain about the essence about why do we see this, this type of attack getting more and more interest from the attacker point of view. And now I would like to get you into the mindset of the attacker. If you would have to, for instance, if I would take like one of the giant top 5 companies in the world, you can imagine like a few, and I would say try to get and compromise, like gain access to one of those networks, so one of those organizations. So from an attacker point of view, you have the target company that you wish to compromise or you wish to get an initial foothold in. And you can do, I would say, the most interesting way or the quickest way would have been if you could just, from the network, trigger an exploit, gain access to the servers in the DMZ, and then exploit more and more until you get to the where the data is reside and where is the, I would say, the secrets of that company. So that's one approach, and it's pretty much costs a lot. And you can see here a screenshot from Zerodium, which is a website that does like associated with 0 days. You can see the cost of having like Windows 0-click exploit, and you see the price tag of this is like $1 million. It's cost a lot. So obviously this is the most intuitive way. Another approach we need to do like phishing campaign. And we see that there are a lot of awareness about don't open emails, don't open attachments that might be malicious or unfamiliar. And this is also something that costs from an attacker point of view a lot, in a sense that they would need to find a good, I would say, context where the email is being sent, find the people, deliver it. So a lot of work needs to be done. And that's all in all, in order to compromise one company, one person at one place. And I would say that the thing about software supply chain attacks is that you can have a very good return of investment from an attacker point of view. If you would find a way to do those manipulations that would allow the attacker to inject malicious code, it's pretty much, I would say, a low effort, because you do need to do some work. It's not like anyone can do it, but it's not. You can see later on when we will describe the different attacks, you would see that it's not that hard. It's something that you have development background or some DevOps background. You see, it's not that hard, and you can pretty much with low effort execute the attack. And what would happen is that if you were able to compromise one of the major or main libraries, you would immediately get a wide spread of the malware. So at one shot, or I would say at one effort, you can essentially compromise many, many companies. So if I, again, go to the top 5 companies or top 10, so assume that instead of chasing one after the other, with supply chain attack, you can amplify the attack in a sense that if you get a software component that is malicious being installed on many organizations, you can, within one attack vector, compromise hundreds of companies at one shot. And what actually makes this attack go back one slide, because I want to touch the last bullet about the fact that about the fact that eventually people trust the software. I mean, if you look at your Windows workstation, you trust Microsoft. If you use Google Chrome, you trust Google. So all of this trust relation and the fact that within the supply chain attack, you can inject the code that will eventually become a legit piece of software from a known brand that might even use digital signatures to sign this end binary. Eventually, this will be delivered, and by having this attack, you pretty much can abuse the trust relation between different companies. So that's why this attack is so interesting and so appealing, I would say, for attackers, and we see more and more from that. On the next slide, you can see that what are the options for an attacker. So essentially, from the attacker mindset, there are two things or two types of payloads that can be integrated as part of the malicious code. One could be to set up a backdoor. If me as an attacker would have been able to compromise and change some code at the component, I can essentially set up a backdoor that can eventually be used And if you think about the whole security method of identifying CVEs and mitigating risk and so if you can think about it, a CVE is a known vulnerability, but the world today have more than the number of CVEs. The number of vulnerabilities is much larger than the number of CVEs that exist today in the world. So there are a lot of vulnerabilities out there that have not been yet discovered and don't have an official CVE number. So an attacker can set up a backdoor that would seem like a vulnerability that would eventually be registered as a CV. But just think about the potential of having this silent mode of just putting a backdoor and then exploiting this later on. Another approach is to set up malicious code. What if I can not set up as a backdoor, but have this malicious code embedded into the software component that upon build process, it will eventually execute this malicious code on the target companies. And we'll see later on that, for instance, SolarWinds was kind of this approach by having a very sophisticated malicious code that was very silent.
So speaking of that, how do these attacks occur, right? So, I mean, the thing is that exactly what, Asaf mentioned is that, by the way, these are attacks on your credibility as software provider if you're doing this, which is actually in some ways more damaging than some of the initial costs that come associated with it, such as, in some cases it's blackmailing, in other cases it's releasing of customer information or whatnot, but damaged reputation is much harder to actually go ahead and recover from. So when we have these attacks, I mean, when you have your typical situation, and I'm a developer and I'm on a team and I have CI processes and all these things that are involved in it, and I'm building my code, of course I depend on transitive dependencies. And these transitive dependencies that you depend on are susceptible, right? Because a lot of them are public and open source and they're free on the market, and your developers use that to accomplish the tasks that they've been given. And when you do this, you compile your code, you put together, say, in this case, like an EXE or a web service or whatever you're building, it doesn't make a difference. But if it's your software you're delivering to your consumers, whether it's downloadable or it's something else, the thing is that, understanding if there's something compromising it, suddenly you've actually discredited yourself and you've actually corrupted the executable or the software you're providing. And when you provide this to your customer, you're providing it to them. But it's not only the direct dependencies, and this is one of the things that comes about, because a lot of focus we see on some of these attacks and what we see people talking about in the market is not only just the direct dependencies, but those dependencies have dependencies. And those dependencies are also susceptible. So when we talk about SolarWinds in a little bit, one of these methodologies in which SolarWinds was an actual component was the fact that one of the indirect dependencies to the software they were creating was actually susceptible. It was introduced as part of the larger transitive dependency. And once again, we're in that same construct of having this, suddenly this nefarious component inside the software that's sitting there and wait. And when we deliver to our customer, unbeknownst to them, suddenly, there is an issue. And in some of these cases, and like I said, when we keep talking about things like SolarWinds, because it was so sophisticated, I mean, one of the key features of that was the fact that it had a 14-day backdoor policy. From the time it was installed, the timer started, and 14 days later, it executed its code, which compromised the system that was associated to it. So, just as a side thing, we're going to do a quick poll here. What is the average amount of transitive dependencies that is used in software today? So one of the things, think to yourself, if I'm a developer and I'm looking, or you have developers on your team, how much of that software that you're building is comprised of dependencies? And I think we're going through a poll. So we have 20 to 30%, 30 to 40%, 50 to 60, 70 to 80, or 90 plus. So go ahead and we'll do the poll right now. Let's see here. So if you guys, I think, can go in and do that, that'd be fantastic. Well, I see we got a couple of people doing it. We got a 7 to 64. We'll wait for everybody to come here, but I'm really glad you're all here today to join us on this fun, exciting talk. I feel like we should be playing some music or something, or actually, maybe we can sing a cappella and stuff.
We can sing.
Can I? in the bathroom, like in the shower, maybe. But I'm not going to go there right now. I think that'd be really awkward.
I don't think it's a good idea for me to sing as well. I mean, I can play guitar though. I can play, but cannot sing.
I can go grab mine off the wall if you'd like, and we can maybe do a little bit of a duet, and figure something out. All right, we're about halfway. We're about halfway there with the voting. Come on, people, jump in. I feel like we're raising money. I feel like, dig deep, give back to the community. I feel like we're doing we're raising money for something. Or we got one more person. Come on, everybody, get in here, donate, give to somebody who needs it, like us. 32. All right, who's holding back here? Come on, you got clicks, you got mouses, you can click on those buttons. Let's do it. I'm going to give it another 30 seconds. Whoever wants to jump in. Oh, we got more people attending, so now the count went up. So now we're under 50% of the people. All right. Oh, one more. All right, I'm going to give you another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, and Yahtzee. Let's go take a look at our poll. So, all right. Hey, here we go. So let's see here. We got 20, 0 for 20%. That's a good idea. 30 to 40, 50 to 60 is the highest one here, huh? 70 to 80, and we have here, and then 90 plus. Well, I will tell you that right now that actually, when we talk about this, 85 to 95%, 90% of your software is someone else's software. Yes, that's actually a scary figure when you think about that, right? You are putting a majority of your software development needs into someone else's hands, somebody you don't know, right? So these are people out there that are actually, building components. Your software developers need something for their code. This provides a function for them to do their job. And the funnier part about it is, or the sad part, however you look at it, is out of that 99% of those, 75% of them have at least one open vulnerability. Think about that. You're introducing the fact that you're bringing in the software, and almost all of it has a, 3/4 of it has some sort of susceptibility to it inherently from the moment you start using it. And then on top of that,
like about the poll, Bill?
What's that?
You know what I like about the poll is that if you look at the results, you see that we got right now, I think around like 70-ish people in the audience here, and almost everyone were 50% and above. I mean, it's pretty straightforward, and people now today understand that open source is an integral part, and no one chose the 0 to 20%. And I think this is the very, for me to see like this maturity of visibility, I think it's very tells something about the audience.
Yeah, I was kind of disappointed that we didn't have everybody in there, because I waited for that one person to say, "Well, I do all my own stuff," but that's okay. Like I wanted that one person. But at the same time, the thing is about this though is that when 49% of the code bases were analyzed out there, most of them actually had at least one high risk vulnerability. Once again, you are jeopardizing the things you're doing by introducing these. And of that, the thing is 90% of these applications, right? Those third-party transit dependencies are either outdated by 4 or more years, or they're abandoned. Think about that. Somebody put it out there, like, you look at, some of these, tools, and you look and you see, like, if you go to their GitHub projects, you'll see that, it hasn't been updated in 4 years. And here you are, you're running the newest, latest, most awesome application on the market, and you're using stuff that's 4 years old. It's like you're building a car, and you're like, I'm not going to put a new motor in. I'm going to go to the junkyard. I'm going to go grab a junk motor. And it works, but does it really work? Does it really fit what I'm trying to do with my new hot sports car, right? It's like, same idea. And the thing is that if you have all the proper information, and one of the things that we're going to talk about today is that, we're going to show you ways to combat this, of course. But one of the simplest ways you can combat this is actually just by looking at the libraries you're using, looking to see if there's anything. And we're going to talk about remediation later on how you can attribute to this. And in this case, since this is, sponsored JFrog, talk, we are going to show the product, and I am going to show you how you can actually, use remediation to address this so that you can lessen the ability for, vulnerabilities and actually exposure of your company and such. So when software attacks, Go ahead.
So if you look technically on how those type of attacks are occurring, so we're gonna technically explain, like, I would say, the main methods that are being used recently and were published. So the first one that we're going to cover is, I would say, seems like a straightforward one, but still we get this a lot. Bill, maybe you can jump to the next slide. And the first one is essentially dependency typo squatting. So if you refer to the definition that we had at start about some malicious code was yada, yada, yada into a trusted piece of software. And the thing that we added in this slide is that which is written by humans. And the thing that we need to remember also from security as well as like QA and every aspect of the development of the software, that people make mistakes. Software has bugs. It's not because people are bad. It's just, things happen. Same for this thing. The dependency typo squatting is essentially a method that attackers use in a sense that they take, I would say, very known components, and they just create another component with a very similar name. Pretty much close to the name of the very known component. And when developers go and just very easily do pip install or just get a component from a public repository, by accident get the wrong component which has a similar name and they just do a typo. And what happens is that instead of having the original library that you have some modified version of this, and this is, I would say, very basic and intuitive that you want to go to the developer and say, well, just don't do a typo. But a typo by definition is a mistake. And you would think that you would never fall for it, right? But it turns out that a lot of people do. We at JFrog Security, we have people that continuously scan open repositories and try to find malicious code And on late July, we disclosed we created a scanner that will scan the repository. And we disclosed several malicious packages on PyPy that were found to be malicious and essentially contain the malware inside. And we found that those software components were uploaded by a single user that we don't know who it is, but a single user uploaded many of those components that looks like the original ones. And 30,000 downloads were happening to those software components, to those malicious ones. We don't know where it has been spread out, and you can see the article in the Hacker News and also in the JFrog security blog, and it was published in many other publications, I would say. But essentially, you see the amount of the amplification of the attack. The attacker put one software component with a different name close to the main one, and 30,000 downloads. And what does it contain, those malicious code? This malicious code that we analyzed essentially was malicious code that would grab credit cards, it would grab passwords, and it would compromise the machine. So all of the things that you would say, seems like an attacker would go through the phishing and those, I would say, traditional security, traditional hacking. You see this targeting towards developers and towards getting access to those companies. So this is one type of attack vector.
Well, it's funny let me just chime in for a second, because actually one of the things we'll talk about in a minute is another type. But at the same time, I actually had a chance to work with one of our customers, and a very exquisite customer. They have a very amazing sense around security, and they provided me with a list of a simple typo squatting technique that was used, and it was in the spelling. So the spelling of the binary actually had the IE in it. So if you're familiar with the English language, I before E except after C. And all these people did is they found a whole bunch of libraries that had I and E in part of the name, the descriptive name, and reversed it. because it's a very natural thing for someone who actually type it in. But the ones they were bringing in terms of typoing wise, was a simple mistake of I before E, and they had E and I, and it caused a bunch of confusion in that respect.
And the second type of attack, is like not towards, I would say, third-party components. So people get the third-party components are risky, and you should watch an eye for those type of squatting, and you can keep your eyes. But at least I know that my first-party code, the libraries that I create within my company, this is my code. I'm safe. I got nothing to be worried about. But it turns out that this was a recent technique. I would say earlier this year that there is a technical article about how to implement this, and you would be amazed how easy it was and how sophisticated and smart this attack is. Essentially, dependency confusion is the fact that takes advantage of the fact that build system would prefer public repositories over private repositories. So that means that if you have your first-party code and you would like to do linkage against one of those I would say first-party component. So if the same name exists externally, that would confuse the build system that would grab this malicious code. And there was a security researcher that demonstrated this attack, and he did it very responsibly. So he did it step by step, coordinated with all of those companies and so. But in his proof of concept, he was able to compromise hundreds of companies and breach over 35 major companies. You can see the logos in here, and was able to prove that this attacker would gain remote code execution and compromise computers within the target companies. So this, you can see again the amplification, and he got $130,000 of bounty because of this attack. Very interesting one.
Oh, and one of the other interesting bits. There we go. So the thing is that as part of the supply chain attack is another thing you have to be careful of. By the way, is also that some of these are actually, some of these repositories, you might be pulling from. You might think they're trusted, right? They're a trusted source, so you immediately jump in. So the highlighted ones that I have here in the snippet I have, you can see here, there's a thing for PayPal. Now the thing is that actually those sources right there were not PayPal. Somebody actually went in and said, hey, I'm going to name these PayPal. So this is one of the things is it was from a public repository instead of a private repository when you're doing this. And the thing is that pulling these in will cause that kind of level where you're like, oh, it's PayPal, it's a trusted source. But how do you know, right? And that's one of the key differences here, is the fact that we're going to show you actually, and Asaf kind of alluded to it, one of the things that we have in the Artifactory product is called repo prioritization, and we'll talk about that later on as a way to combat this, in addition to other things that we offer. But you have defenses against this. You have the ability that once you find a trusted source to stay with it, even if in this case, say that somebody does also, say, release a version of a binary that they have with the same name but a newer version, that also could be a confusion, and we'll definitely talk about that. And of course, we've alluded to it many times as we've discussed SolarWinds, right? And if you're not familiar with it, of course, I'm sure everybody's read about it. Everybody in this call is at least had something or read about it, or maybe been influenced by it or affected by it. But the idea was that over 18,000 customers were affected by this, and this came down to actually simply a transitive dependency that was injected into the supply chain for the actual composition of the SolarWinds Orion product. And this simple little binary, it wasn't even that big, actually. It was only a couple of megabytes. But the thing is, though, it went undetected. But it came in as an indirect transitive dependency. It was actually a very complex attack in which they did this. Is what they did is that one of the libraries that was used to build Orion, these people actually associated a new indirect dependency, so that when the direct dependency was brought in to compile the product, it brought it in with it. And it came undetected. It was very small. It was innocuous. Nobody really thought anything about it until they started to dive into it. And as I stated before, what the big thing it did is that it set a timer. So it wasn't even an immediate effect. It was one of these effects that when the software went in, 14 days later, it started to do its magic, which was to go ahead and start opening ports, start opening remote calls, basically saying, hey, world, here's everything I have, jump right in. And these hackers knew what to look for, and they were able to go in and trace the usage. Because it was put into a repository that was basically public, they were able to go in and say, who has been downloading this, and they could actually trace it down, and they were able to go and attack based on the information they were getting back from the RPC calls that it was actually doing. So let's go jump to the next part. And now we're going to get into the fun stuff, right? The best defense is a good offense. And when we start, what we mean up at is that, like, you know, first of all, one of the biggest factors of actually building your software is actually understanding what your software is made from. I mean, I come from a development background going back, there's actually a guy on the call here, he's known me for about as long as I've been doing this, going back into the, here we go, ready to date myself, the late 90s. And, you know, the thing is that, you know, building your software, you're always, as a developer, looking for ways to do the things you need to do and do it easier, and to find people who have actually taken some of the heartache out of it, where it's, you know, being able to go ahead and, like, change a variable type, or, you know, a variable value, or, you know, do a presentation layer in a website or whatever. Doesn't make a difference. Whatever you're building, you have an assumption made. And the thing is that there's a good faith aspect as a developer to think that anything that I'm using to build my code, I'm putting trust in there. Once again, I don't know these people, but I'm assuming they're like me. But they're not. You know, there are people out there who definitely want to do harm. In some cases, there's white hat, you know, hackers that are doing this to say, hey, look, you're exposed. And then there's others that are like, we want to take all your money, we want to ransom your company, whatever. So understanding how your software is actually being, you know, what's inside that counts is really a major factor behind this. And, you know, we mentioned SolarWinds, and SolarWinds, the United States actually back in May of 2021, the Biden administration enacted the executive order on improving the nation's cybersecurity. Now, it's a very lengthy document that explains a lot of different aspects behind it, but one of the key takeaways from it is also the idea, it was an answer to the actual SolarWinds attack and others, because remember, actually SolarWinds, there was a lot of government agencies like the Department of Defense and others that were actually affected by this. And so the Biden administration took it upon themselves to go, hey, we're going to enact this quickly. And just so you know, this isn't new. This has been going on for a little while, and we'll talk about this. But the major piece of it is the fact that, you know, buried in here in the actual full document is Section 4, enhancing the software supply chain security. And one of the major pieces of this is that if you want to work with the United States government, and if you've also know over time that, you know, these kind of mandates or these kind of things with the U.S. government usually bleed into the private sector. So part of this is also an education as what is a software bill of materials? Because the United States government clearly states if you wish to work with this, you need to go ahead and supply us with this, because they want to be able to see everything from what's inside, and also things like license and governance. And we're going to go into details on this in a bit, but this was a way to ensure, and like I said, a majority of you know, different organizations when it comes to now like the industries of like medtech and fintech and others, you know, that deal with sensitive data are going to adhere to this. And actually probably in the future, very, very soon in the future, a lot of companies, when they go to purchase your software or go to use your software, you know, some companies ask for like SOC 2 compliance documentation and things like that. Soon they're going to be asking you for, as part of the delivery, can we have your software bill of materials, because we want to know what we're actually purchasing. And knowing that, because of the fact is that if you need to know where the actual inception came from, and the reason why I'm showing some delicious German chocolate delight here is the fact that the portion of the actual government that enacted this idea is the FDA, the Food and Drug Administration. And the reason why is this was actually a call to action around software developers and companies that make software for things like medical devices. You know, if you're putting software into a device that is meant to keep somebody alive and there's malicious code in there that could potentially kill someone, or say an insulin pump that's not working correctly, or a heart rate monitor that isn't working properly, things like that, you want to know what's inside so that you can address it. It's very similar to having ingredients inside anything that you cook. The Food and Drug Administration says you need to tell all the consumers what they're consuming and also give applicable warnings to say that certain people that have any sort of allergies to these, they need to be made aware so that when they buy this, they know what they're getting. And the real driver behind this too, was, like I said, was also the national, the NTIA, which is just a fun acronym to say. But the thing is, back in 2018, they worked with the Food and Drug Administration to provide the Software Transparency Project. And this was, like I said, a way for device manufacturers for medical devices to have an accountability behind what they're producing to make sure that if they did put something into the software that is powering the devices that they have, it's a way to inform the consumers that, oh, by the way, here's the list of software that I'm putting in here. Here's some potential threats, and also, too, just some common guidelines behind the software. And knowing that brings you into the idea of what is a software bill of materials? Well, it's simply a list of ingredients of what's inside the software, is what you might think. But the thing is, like, yes, it includes libraries, it includes any properties. Are you using some free and paid components? What kind of data is restricted and accessed as part of this, right? So say you have a product that says, for improvement purposes, you've all seen the warnings. Would you like to notify us of any improvements that we have? And would you like to supply us with the data from what you're doing so that we can make our products better? Well, this is actually some of the kind of access controls you need to notify your customers on. But in addition to this, you also want to make sure that you understand how it was constructed. And we'll discuss that and how you can get that kind of level of information today. A lot of this stuff is not unattainable. There's actually ways to do this. Yes, we will show our products substantially, but at the same time, this is a generalized knowledge for the betterment of mankind, right? This is not just about what we're, us as JFrog saying this. We want to make the world a safer place and through software. And one of the ways to do this is to understand and educate the masses on what this really means. And so, who uses this, right? Who would be the people who would actually want to use this? So it could be everything from the producers of software to keep a catalog on, on change agents, like how we progressed over time and how is our software product, changed. If there's some sort of problem, you can use this information, by the way, and I'll show this later on, as a way for root cause analysis. So say one version behaves differently than another. You could actually use this information to say, what changed objectively between these two versions to cause such a mess? It's also used for people who are doing procurement, right? So people who are choosing to buy software, now giving this to them, some companies have regulations. It comes down to like, we use Zoom as our platform for our conferencing. Some companies have regulations that say you can't use Zoom. It's compromised. Well, why is it compromised? Well, you can always look at the software bill of materials, and maybe there's components inside, or maybe there's license compliance inside that says we can't use anything that's GPL. Or things like that. They might have regulations say, well, this library has been unapproved by our security team due to XYZ. They can parse through this data and understand that. And then when it comes down to people who operate software, once again, it's a nice way to have asset management. It's a nice way to have a direct correlation on how you're actually building, implementing, and distributing your software itself. So this is actually, it's really a multifold kind of thing. It's not just you, it's not just me, it's not just the companies you work with. This is more of a global idea and a global presence. In this way, everybody knows what's going on. So there's, cutting down and mitigating a lot of the risks that are inherent into this kind of situation. So, before we jump into, once again, we're going to talk about the scope and the scale of this. What are the benefits? Once again, identifying, mitigating, and avoiding, right? These are kind of the top level items that you have right away. One of the things we'll talk about later on is remediation. Another thing is your legal team will are going to start hounding you. Hey guys, you know what? You're making this software. We need to provide to a customer. We want to make sure that the licensing, that the license you have adheres to our standard. Our legal team said these are the licenses for software components, because every software component should have a license, and if it doesn't, you should discard it immediately. But every license component that you have should have a license, and those licenses, things like medtech and fintech have very stringent policies by their security teams, their infosec teams, on what licensing they can use. But also being able to go ahead and look and actually be able to mitigate risk over time, right? Understanding what's in there is an excellent way of having that high-level picture of your software. It's not just what you produce, but it's everything else associated to it. And in addition to that, it's just a nice way to also lower operational costs, because you have basically a catalog of information to work with. It allows you to go through, and if you do need to do root cause analysis, you do need to do risk assessment, you do the things that make your company more safe and secure. This is just one more piece of the ammunition you need to defend yourself against potential threats by knowing everything you want about it. Asaf, do you want to jump in and you want to add anything, or? So when I look from a security standpoint, the way I see, if I would summarize where we're at right now, so we started with like the attacker mindset and the runtime attacks that can occur to execute the software supply chain, and the defense approach that we see so far is that they say, well, it's happening. And the way we can have visibility towards those processes, essentially to start to aggregate a lot of data. So right now we're in the position that SBOM, some companies already collect this, some companies not. But if I would look 5 years from now, we're going to have so much information that first it will have to get transparency between parties. So if I create a software, I can know what are in the libraries that I get, for instance, as well as the asset owner can know at the end product what they get. And let's assume that something occurred. So we have, for instance, the new SolarWinds or the next attack. We can get traceability immediately and identifying what are the blind spots. So the defense approach is about start to collect data so we can start to manage this and handle this. And before that, we were discussing about attacks at runtime. What are the attacks that occur? Like, how do they occur? And later on, by the way, just the way I'm doing these summaries, because later on we're going to address both the aspects of how do you do runtime protections, as well as how do you collect this information that we described right now. Excellent. Thanks, Asaf. So once again, we're back here again, right? So we have the idea of compiling your software, using your transitive dependencies, and putting, if you find out there's something in your code, and then suddenly you're back to where you began again, right? You're now delivering potentially threatening software to your, any sort of external source. Then on top of that, we talked about, once again, my screen went blank. There we go. Transitive dependencies, both direct and indirect, and how they can do that. Well, one of the key factors here is I'm waiting for the slide deck to catch up. There we go. For some reason, it's taking a second here. It's not liking my clicks. But let's go to the next phase, which is, well, that's great. But what if the fact is that, when you have this software and these transitive dependencies, and when you're building it, one of the nice things you can do is, of course, have the software bill of materials. Now, with the software bill of materials, one of the nice features about this is that, when you do find, say, something that's actually nefarious in this case, you now have a record of actually, is there something nefarious inside? Or maybe there's something that's potentially threatening, something that's identified. Asaf talked about things that may not have a CVE yet, but might be on the radar, such as, one of the things is that with CVE information, you have everything from low to critical. But a lot of people ignore the info and warnings, because some of the info and warnings that you actually get are saying, by the way, that there are potential threats that are being assessed at this time, right? This might potentially be something, and it might get upgraded to a CVE and actually have one. And those things is that inside, you can have that in your manifest, in your software bill of materials, so that when you do identify something potentially threatening and you tell your customers, when you supply it to them, they can go in themselves and look at the software bill of materials, and so can you to say, hey, by the way, you know what? this has actually been affecting, the software we gave you, and this customer was like, hey, we were just going to ring you on that. And, at least there's a same page. And the thing is at least there's awareness, right? Awareness and a way for you to go in and actually address it. But the best part, too, is if you start collecting your software bill of materials and you have, say, a vulnerability that's been found at some point, with the software bill of materials, you can go ahead and say, hey, by the way, let's go look at the versions that we've released over time. And you can say, oh, you know what? Between 1.1 and 1.3, we actually released this to it. So once again, root cause analysis, remediation, and action. Right? This gives you the ability to also cut down on the amount of time it would take you to go ahead and research this. The thing is, by not having this kind of level of competency with your binaries, Artifactory provides you with a level of competency, is the fact that this allows you to go in and look at this information and see how far does it go. I call it blast rate, right? Because when you find something, you want to know how far it goes, and this will allow you to go in and trace it so that you can see what's affected over time. Now, the same thing goes when you have highly complex components, like, say, Docker. Remember, people always talk about Docker, but remember, Docker is not just a place to host your application. It has many different components. It has the app layer. It has the runtime to run the application, and it also has the operating system. And you should be able to actually produce a bill of materials for this, right? You need to be able to produce a bill of materials that shows all the content. And I'm going to show you an example of that today, actually. You also, when you have, like, say, large-scale services, when you start looking at things like web services, which are like Helm charts and, say, other, multiple Docker images, like this can be another thing. This also is another layer that you can actually have a software bill of materials. It's basically you have a bill of materials for each component, and then you can also have an overarching bill of materials. And one of the things that we have at JFrog is this concept of release bundles. And a release bundles allows you to pull together various different software together into a singular release that's digitally signed, but also, too, it can provide you with a manifest, a bill of materials for a bill of materials. So you know what the entirety of the actual service itself is. So, yes, we're throwing a lot at you right now. And the whole thing is that, we understand you're in DevOps or DevSecOps, right? I always say DevSecOps. I try to avoid DevOps now because, security shouldn't even be an afterthought. It should be part of everything that you do. It should be a mindset that you gain as part of the DevOps organization. But, of course, fires are going on constantly. You're trying to keep going. How do you keep control of this, right? So I'm going to talk about one thing. I'm just going to go through and talk about the JFrog platform for a few minutes. Then we're going to take a break. I'm going to give a quick demonstration of some of the pieces, and we're going to show how to defend yourself as an actual software, company utilizing some of our components. So, of course, we have our typical development workflow that we kind of started talking about a little bit before. I'm a developer. I've been given a task. You need to build a project. I chose NPM in this case. Of course, when I build my project, one of the things I'm going to do is define what transitive dependencies do I need to create my software as a developer. What am I going to need? And of course, as I have a larger team and as I start using CI tools, we'll talk about that in a bit. But as a developer, I've got to start somewhere. So, of course, I define my package.json. I put all my information in. It could be everything from a POM file in Maven. It could be a Go mod file if you're using Go. It could be a Docker file if you're doing Docker. It doesn't make a difference because once again, I depend on third-party transitive dependencies. If you use NPM, guys, you'll know the joke is the fact that you put one library and 200,000 come along with it because just the way NPM works. But this in itself is okay. The problem is there's no consistency. There's no accountability. So now let's go ahead and, this is our Artifactory. If you're not familiar, I'm assuming if you're here, you've heard of us, you know what we do. We're Universal Binary Repository Manager. But the thing is that what we do as an organization and where we supply you with the tools you need to get through this is the fact that when you implement Artifactory as part of the solution, you're actually going to proxy those third-party transitive requests from the source, right, in this case maybe NPM, to its destination, the developer or CI tool, And the way you do that in Artifactory is through a thing called a remote repository. A remote repository is a lazy proxy so that when the requests come through Artifactory to the remote source, they come in and they cache inside of the remote layer. Later on, we're going to talk about X-ray on how you can evaluate these to stop yourself from having things nefarious. But the idea of the remote repository is the fact that if you say you have 1,000 developers and you're all working on the same project, and developer 0 pulls down the binary and you're using Artifactory, the actual the module, the library, whatever you're using, will go into the remote repository and will be delivered to the developer, and then all 999 other developers will go ahead and pull that same binary. By the way, this does one thing that everybody asks me to boil down what we do, and I say we provide a consistency engine. You're providing consistency of development methods for your developers and tools to create your software. So you're also going to produce software, right? Because you're also going to go ahead and you're going to want to go ahead and build things. So that's where Artifactory has local repositories. This is where you store your binaries, your Docker images, your Maven builds, or whatnot. And then what you could do is just a little best practices thing here, is that you can actually design your repositories to match your software development lifecycle. We have a promotion API that allows you to promote those builds you create through that lifecycle, providing accountability. And we're going to talk about accountability, and we're going to talk about SDLC as part of this, because that is an essential part that you can include in your software bill of materials. Maybe such things, even if it's not the full bill of materials you can supply to your customer, but it might be part of actually the knowledge base you have in the software you produce internally to say, hey, there's a problem with the software. Did it pass QA? And we'll talk about that in a bit. But then we also encapsulate everything for ease of use into a virtual repository, which allows a single entry point into this multi-repository method. And the thing is, we've made it super easy to implement. If you use our product, you know we have set me up instructions on how to do this. But what you're doing is that you're actually going ahead and you're actually taking the stuff you're doing, pointing it to Artifactory, and now you're actually going ahead and you have a place to store those transitive dependencies, indirect and direct. You have a place to store your builds. You have accountability so you can build a software bill of materials. And we'll talk about the information you gather with that. But in addition, once you do this, there's no change in some way to the things that you're doing. So NPM in this case still works. And if you want to use our JFrog CLI tool, it'll work. But then you're using Artifactory to pull these in. The next thing is adding that layer of security. So this is where our X-ray product comes in. This allows you, and we'll show you in a bit, on how you can look at the issues that you might be facing in terms of CVE. We're going to talk about license compliance and governance as part of this. But this is also another way for you to go in and attack. Right? This is your attack. Your attack vector on defending yourself is actually being proactive. And the X-ray product allows you to be proactive. We'll talk about shift left, the idea of the onus on the developer, how to integrate into your CI process, and also part of your release process. But of course, this is only one part of it, because once you've actually gone ahead and built this, you've implemented some layer of security, you're going to want to automate this. And so whether you use your own CI tool or you can use our tool, which is a CI, CD, and CI orchestrator, this really gives you the ability to start automating these processes and ensuring things. And we'll talk about ways of accountability as part of your CI process, how to extend it, and also a way for you to go in and have justifiable cause on how those actual phases, those steps are actually being done with digital ways of actually having accountability behind that too. And then lastly, it just doesn't stop there. So of course, you're going to want to extend this out and have it as part of your distribution too. So we actually have an inherent distribution component called, surprisingly enough, distribution. And one of the key components of this is being able to separate out your CI from your CD. So what you're producing and manufacturing and what you're delivering, whether it's a web service, whether it's the IoT devices, automobiles, medical devices, whatnot, but do it in such a way that is safe and secure. And once again, this goes back to accountability. This is information you can include in your software bill of materials. Understanding not only its inception, right, from the developer, but also down to its consumption, its distribution, right, its deployment. So I always like to say when people ask us what we do, and I say, well, our platform, which includes everything here, can be everything from developer to deployment, code to cloud, developer to device, with the military to the compile to combat, whatever you want to say. But this provides you with an end-to-end solution. But not only that, all the other ancillary kind of technology you can be integrated into it too. And at the end of the whole cycle, you can have a level of actual information, software bill of materials in this case, or we like to say also it could almost be an enterprise bill of materials because it has everything, or a deployment bill of materials. You can segment pieces of this out from the information we actually gather. But this gives you a way for you to have end-to-end abilities here. So I think we're going to take a quick 5-minute break, I believe.
For me, if I would like just to add like a few words. So while we have the 5 minutes break, I hope it was interesting so far. I do encourage you to write down questions in case you have. You can just drop them in the chat. So during the 5-minute break, we can review those and think how can we answer those during the time that is left. So let's take a 5-minute break.
We still have a lot of fun time ahead of us, and we have another half hour, so we'll do 5 minutes. We'll see you guys at 1 p.m. or wherever you are. Tell me 1 p.m. PST. So we're going to mute ourselves for a minute, and then, like Saf said, if you have any questions, put them into the QA box, and then we'll go from there. All right. I think we're back. Everyone? Maybe? All right, everybody. It is 1 o'clock, and let's get rocking here. Let's get to the next part. So the next part is, of course, life cycle of a binary demo. This is where I'm just going to show you a couple of things, because I just want to be able to show you how you can use Artifactory for a couple of things. I'm only going to take about 5 minutes. I was planning on doing a little longer demo, but I want to make sure we leave enough time at the end to discuss. But let's go take a look. And let me share my screen for a minute. It's taking a minute here. Hold on a sec. Come on, share. All right, so, oops, I've got for some reason it was sharing the wrong one. Hold on here. Having a technical problem for a second. Let's see here. I think this is the one. Let's see, share. Good enough. All right, so let's take a look for a second. So this is actually one of the latest versions of Artifactory that we have out here. And so I'm going to log in and I want to talk about a couple of things. And some of the things that we're going to talk about today is the fact is, understanding, where binaries come from, right? So in other words, really quickly, just as a recap, of course, we have our our repository structures. We have local, remote, and virtual. Local is what matters to you. Remote is those third-party transitive dependencies. And the last one, of course, is virtual, which is the encapsulation. When you define your repositories, I talked about the fact that you can go in and define your SDLC. So I've got like dev, I've got QA, I've got production. I think I have a staging one here somewhere. In addition to that, I depend on third-party transitives. And one of the questions actually came up was, I noticed that somebody asked about, how do I do exclusion? How do I ensure that those sources that I'm pulling from are the ones that we wish to use? So let's go look at something like, say, npm remote, for example. This is actually one of the most notorious sets of libraries out there that are compromised in some respects. So a couple ways that you could go ahead and make sure that you're not bringing anything nefarious is a couple different ways. So first of all, with the X-ray product itself, it gives you the ability to go in and say that you want to scan it, and you could pay rules on this, right, to go ahead and ensure that you're not bringing anything nefarious in, and I'll talk about that in a second. But there's two methods in here that I'm going to go into a little bit of detail on what that means, and one of them is this. So first of all, include patterns and exclude patterns. These are regular expressions. If you have known ones that you do not want to do, that you discover over time, you can go in here and say, I want to include these, but I want to exclude these. Exclude patterns and regular expressions are your friends. When you index an X-ray, you're going to be able to talk about that in a second, but the fact is with indexing an X-ray, this is actually letting just our X-ray product know what libraries you wish to go in and evaluate. And by the way, this applies also to local repositories, so do not forget that. But in our advanced features, one of the things that we have here is this idea of priority resolution. And the idea here is saying that if I have binaries in this repository, these are the ones that I wish to use. So the ones that are there, these are a way for you to kind of lock into the versions that you're utilizing. So this way, if there is a new one that might be susceptible, you can still bring it in and you can evaluate it. But when you actually pull from the source, it will pull from the trusted sources that you have already. You can designate those. I'm going to send out, there's information on our website behind that, and I don't have time to go into full details, but this is actually one of the ways in which you can utilize this. And when we start talking about, understanding the actual, how do you, evaluate binaries, how do you evaluate those binaries that are pulled in, that's where X-ray product comes in, and it's actually being handled through things called policies and watches. And these are active approaches that you can take. So you create policies that are based either on security or licensing. And when you have security rules, you can have a series of rules and then a set of criteria. So if you were to think about it programmatically, the criteria is the if statement and the actions are the then. And now this is where it really comes to pass on understanding what you're bringing in. So first of all, you can make a determination on things that have known CVEs, so from low to critical. And remember I mentioned info and warning, because sometimes this provides information that something is being evaluated by someone somewhere of a potential threat. So you have all severities also. Or if you're more, a lot of newer DevSecOps shops are going more of the CVSS score route, right? It's a more comprehensive score than just low to critical. It actually gives you details on why this is a potentially nefarious component. And of course, you set your range in which you want to have that. If you're familiar with CVE, a CVSS score, it's based on ranges. So say in this case, I went from 3.2 to 6.1. What do I do? So under our actions, we have, of course, it'll generate a violation associated to the binary in question. You can also do things more proactively. So you can actually also do things such as, maybe something is found, we have webhooks. So you can actually say notify somebody like a Slack channel or create a Jira ticket or, do things like that. And it's a JSON post and it does instant notifications on that. When you apply these to either your repositories, your builds, or your projects inside of Artifactory, one of the fields that it has, one of the parameters, is an email list. So it can be a recipient list, an individual, or whatnot. This will actually go ahead and notify that person. The other thing, too, is if anybody's using the deployer mechanisms, this will actually notify deployers that there's something potentially nefarious here and provide the level of information behind why it is. If, say, you have something that's a little bit more on the critical side, right, a more critical issue, you might want to not notify the entire list. You might want to have a separate email list, and the separate email list could be like Red Team or whatever, as a way to notify them there's something critical or a CVSS score of like 9.0 to 10. Now, the next features are going to actually segue into the more aggressive features, and these are ones that I give a cautionary tale to most of our customers to say, you know what, evaluate the way you're building your software first and then implement these afterwards when you've kind of gotten adjusted to the idea of that your software is probably containing a lot of bad things. But these other ones are more of the active approach. So we have block download. Block download will stop the consumption by any person or tool from that moment forward if something is found that is already stored in Artifactory, such as the third-party transit dependency. But how do you ensure safety before this happens? And this comes in twofold. So you can do more active, which is block unscanned artifacts, meaning your developers can pull in these third-party transit dependencies. They come into Artifactory. They're evaluated by X-Ray. If they pass your criteria, they're released to the developer. If they do not, they are blocked and they receive an error message. But we're going to talk about that's one way to do things. And we're going to talk about shift left in a minute, but let me continue on here. Because the next part of this is that we also have is things like block release bundle. We talked about the distribution process. We talked about being able to take a bunch of different software together or even individual software, digitally sign it and distribute it out. We can actually evaluate the actual release bundle before it gets to the edge level components. Then, of course, we have our CI termination event. The CI termination event will just send an exit signal to basically a CI, CLI, a IDE, just saying, hey, fail the build if something is in process. We also have the same thing around license and compliance. So for this, though, the actual actions are just as severe as we have everything else. The difference is the criteria is different. We have allowed licenses. We have all 435 open source licenses. You can add your own licenses in here, too. This is where you would work with your legal team to say, here's what we allow and here's what we don't. So, of course, we have banned licenses. Now, the really scary ones are third-party direct and indirect dependencies that come in that have no license, or an unknown license. You have the ability to stop that. You have the ability to flag a binary to say, we don't know what this license is. We should probably investigate it. And then we have the other way, too, where some people will actually compromise binaries by having something like a GPL or a regularly publicly available license, and then supplement it either with additional license or a custom license. And this will allow you to go ahead and flag those also. But once you've actually gone in and you've actually built this out and you've built out some rules and policies and you determine, and the way, by the way you apply these actual pieces is through things called watches, where you can apply it to your projects, your repositories, your builds, or your bundles. Once you've actually got these in place, I want to show you what some of the results of this are. So you have a couple of different methodologies in which you can do this. First of all, you have the watch violations, right? So this is all those watches you've created, and this will actually return to you any of the information, say, around any of the binaries in totality, right? So you can, search for a CVE, you can look for all the low, the criticals, whatever. You can also go in and search by specific CVE or by name or content. It was, when was the actual CVE created? And on top of that, you could say, I want to look at security and licensing. You can produce reports, and with the reports, you can produce reports on vulnerabilities, license diligence, violation. You can do it at the repository, the build, the release bundle, or project level. But my favorite is when you're actively going in and looking at a bill, and now when we talk about software bill of materials, what I'm about to show you is a good start. So let's go look at a potential build I have, okay? So what kind of information do I get by using a tool like Artifactory? I'm using Artifactory because that's us, right? But this could be any tool that has this kind of assessment of data. But just to show you that if you are using this, this is something that you can use immediately to kickstart what you're doing. So first of all, if you're publishing your builds into Artifactory, now I'm using a Jenkins server in this case. I'm also using our promotion API, so thus you can see that it was released. I'm using that to say, here is where it is inside of the stages of my SDLC, and I immediately know that there's something critical in nature behind it. But when you have this information, it's not just about what you produce, but it's how it was produced and what's contained in it. So first of all, here's all our standard Docker image layers, right? Everybody knows what this looks like. You do a Docker pull, you do a Docker run, and then you have it. But also, too, I can also show you that here is my actual interface. I can say, hey, here's my Node front end and my Java backend. These are the applications I am hosting inside this container. And say something goes bad with these, and suddenly build number 76 is terrible, and the previous version we had of this was build number 69. Well, here's instant remediation. What changed? What changed between these versions? And I can see that my Java backend and my Node front end had changed, and my Java backend stayed the same, but my Node front end changed. I could even select here and go look at the actual application, and I'll show you that in a bit. But I also understand how it was composed. I understand how this was built. Environmental and system information. These are essential bits of information that you can compile and use. What if the version of Docker changed? What if the Java, version of Java changed? Python, whatever. Maybe somebody left a debug statement in. As simple as that. I mean, a debug statement can degrade the performance of most applications. Then we have the X-ray analysis, right? This is where the nefarious components that could jeopardize your organization come in. So we show you in one location the violations. We show you the security threats. And if I go in here, say I look for a particular one, maybe I look for fast.xml, because I just happen to know I created this, by the way, and my containers are terrible. And I say, oh, look here, I have a critical security issue, but here's the component. I could click on that, but I also have the infected version, and I also have the fixed version. Well, let's take a look. So first of all, remember we talked about that most of the issues you face can be fixed by a simple update. Well, immediately you're presented with the idea of remediation. If I upgrade from the current version that I have to the next version, this will allow me to fix it. But I also want to know what it is I'm fixing. So I have all the information about what this is, the summary. It's a critical issue. It's found as a CVSS v3. It has a CVE number. It has a CVSS score v2 and v3. I have a bunch of reference materials that I can utilize to research this to find out, hey, by the way, there's a vulnerability, but are we using that function? Or maybe it's an internal function. But if you look to the other side of this, the important part is where X-ray excels is this. We actually found a jar of a layer of an image of a build. We went that deep into this, and we found a potentially threatening piece of material. I can also show you from the compliance aspect. Once again, bill of materials. I can show you every single part of this container, app, OS, runtime, and actually show you that these are all the licenses associated to it. I can even export this information as a violation report, a licensing report, a security report, as a CSV, JSON, or PDF, so I can give it to my team so they can fix it. You can even you can actually also get rid of the ideas of that these Docker images are black boxes, because once again, here's our layering, but check this out. Here's a layer. I can see that there's something wrong here because we've actually coded it. I can expand it out and actually show you the contents and their individual actual components, and I can view the component. I can even go ahead and assign custom issues if we find it's lower or higher due to the assessment that we came about. And on top of that, I can have my JIRA issues associated to this, right? So I know it was fixed. You know what? Hey, customer, did you guys fix this? Yeah, we fixed this as part of this build. You can see it was actually fixed as part of this JIRA ticket. And then from a root cause analysis perspective, have we been infected? Well, you can actually go in here and not just do a diff at the app level, you can actually do a diff at the artifact level, the dependency level, the environmental system information. And on top of that, we also have the release history, so you can see all the information about every phase of the SDLC. And on top of that, you can export this all as a JSON that you can ingest into various products. I know somebody brought up CycleMDX and some other standards that are out there, and I'll let Asaf talk about it later on. But we will be actually supporting this towards the later part of the year. And the idea is that we've already built in for years a lot of the material you need to create this, but it doesn't just stop there. Because we also talked about remediation. Now, we talked about remediation at the individual binary level, but what happens if you want to find out how far the rabbit hole goes? So let's go pick a library. I've got a Babel core, right? I see there's 5 versions available. It's been downloaded 247 times. Well, let's go look at this one that has a medium severity. It's been used the most. And when we look at it, the best part is, yeah, here's the README instructions. But I can also show you every single place that this actual binary has been utilized. I can show you every single build that has been compromised by the potential threat of this actual binary. So I know what's been affected, so I can have attribution and remediation and also have action. I have its own X-ray data. If you use our distribution side, you can see if it was distributed out. But then this also correlates. I want to show you how it's all tied together, is the fact that I can go look at this binary. I can look at this all as generalized information. But remember, we talked about direct and indirect transitive dependencies. And one of the key pieces here is the fact that I have all this regular information about this specific binary. But in addition, I also have all the other indirect dependencies that are associated to it. So by having this level of information and utilizing it, you also can go in and not only track it there, but one more thing I want to show you is, as a developer, you have a responsibility to care and take part of your company's security vested interest. So when I show you this, I can also show you that if you use our ID plugins, you can see that I have a software project here. And if I go in and I hover over it, you can see I have X-ray details. But the important part is that we actually go ahead and we can show you the direct and indirect dependencies of any binary that you have at the developer level. Shift left, where the ROI is greatest, I can see the version I'm running, the issues I have, and then we also show you the fact that there's a critical issue. Here's a link to the issue and component, but also direct remediation inside the IDE. Having shift left, having this at the developer level, allows you to attack any of the potential threats to your organization where it matters most, which is in the front line. Your developers are your resource. Utilize them and give them the proper tools they need to ensure your safety and security of your organization. I know that was a lot to fit in a short amount of time in that respect, but just as a quick recap, because I just want you to understand, these are things that I showed you, is number 1, build info. This is all the information you need about every piece of software that you need and the dependencies that it has. Here's an example where I have 474 transitive dependencies. I know every piece of material, direct and indirect, that was utilized as part of this product. We also have the vulnerability portion. How deep does it go, right? And in our case, we're able to expose potential threats to the actual build all the way through, even tar GZs, zip files, jar files, whatever, to find things that might be hidden deep down in the software you produce. I talked about the blast radius, understanding the reach of the binaries. This is another way for you to go in and say, wow, you know what? We've exposed our products to this potential threat for over 30 builds. We should probably do something. I also mentioned the fact that we have, oh, I clicked it, there we go, repo prioritization, right? So this allows you to enable safe repositories, right? Basically, the resolution order allows you to go in and inside of a virtual repository where we have the encapsulation, it gives you the ability to designate certain repositories as trust, right? So this way, when you are doing it, it provides the ability for you to go in and make sure that you maybe use a current version, and then any new versions will be flagged so that you can go in, look at them, examine them before you start utilizing them. Then last thing I have here, is the other parts of the information. What was part of the CI tooling? When was the software built? Did it go through the software development life cycles? How much of that was FOSS? What environments were used? What are the settings of those environments? And also, too, was there security vulnerabilities and also compliance? So having all this additional information allows you to have a comprehensive analysis. We also have additional features, things you can do, such as approval processes. If you use our pipeline product where you can extend your current CI, have it come into Artifactory, you could do things like approvals. Did this pass our muster? Have a manual approval process. You can have that as part of the bill of materials. Yeah, Bob signed off on it. I want to know if it was actually signed by somebody. Did it go through the phases that it needed to be? And you know what? We released this. Did somebody approve it? Also, too, signed pipelines. This is huge. This allows you to have immutable build cycles so that when a build completes or a process or a portion of a process completes, you have an immutable digital signature representing the fact that this was a trusted. Now, this is where it comes down to like zero trust, right? This was a trusted process that you utilized, and having a signed pipeline allows you to have attribution to things that you've done and do it in a way that is indisputable. Then the last part of this, because we want to leave some time, is the fact that all that metadata is exposed as part of the process itself. So when you go in that you can see if has gone through these cycles. And then lastly, I think this is one of the last things I have, is the release bundle. And the release bundle is the end of this, right? We'll be making more announcements about release bundle over the coming months, so stay tuned. But the idea of it is a way for you to encapsulate your software, have a bill of materials for all that level of information, be able to distribute it out and have it in a way. We have air gapping, right? So we have an air gap distribution. This is used for a lot of secure companies we deal with where they want to package their software up digitally, sign it, bring it to another location, and ensure its credibility by using these signatures. In addition, it can encapsulate the RBAC behind it. You can also have our X-ray product stop it before it even goes out the door. And then lastly, you can even integrate it as a native step as part of our solution to ensure this. And then the last part of what I was going to say is having this also being able to track as an extension is going far beyond the reach of actually production, but deployment and utilization. So having all that level of detail and information in the software and the things you produce is a huge thing. And then lastly, we're at the end. Oh, we have a question. Right. Do we have a question? Where is that?
Yeah, we have a lot of questions. So I think we're close to the end, but I think it makes sense to maybe jump in and answer some of the questions here.
Sure. All right. So let's see here. Let's go to the bottom. I see that. Do you have a way? Yes. So I saw that do you have a way to export SBOM information? And if so, do you support Cycle NDS standard? Yes, you can actually pull together information. We're working on a better process of this. And is it towards the end of this year? Is that what we're talking about for exporting the software bill of materials?
So right now in the demo, you've seen that we have several ways to export the information from the Artifactory and also from X-Ray. So we do have the possibility to export it right now to JSON, PDF, and like you saw in the demo. With regards to the Cyclone DX and also SPDX, those are formats that are in the roadmap planning. We plan to store it the end of Q4, maybe Q1, but it is in the immediate planning and people start to work on enabling those features, and those things are in the immediate planning, I would say. So we do have a way to export right now, and we will have some more standards later. So stay tuned, but this is like immediate roadmap.
And this comes down to the other side of this too, is that one of the question is that when you see the metadata being stored that can be used to enforce automated DevSecOps governance by pipeline phase, does this go into the SBOM? You can have this go into the SBOM, or you can publish it to another system. It's simple JSON, and that can be actually utilized. Now I see there's one that says, can patterns be shared across repositories? Well, we just introduced federated repositories, and I'll have to double check. I know that I'm not sure it was this release, but I think we're working on having it so that you can already do properties and stuff in our federated repos. Please just do a JFrog federated repo search. It's a much easier way to do replication, because we already have replication, by the way, across multiple instances and sites. This is just an easier way to do this. But also, too, the export patterns are specific, by the way. Encode and export patterns are specific to the actual repositories themselves, because you want to be able to give granular control and usage. And it says, I see one here. Oops, where did it just go? I see, how does Artifactory know what is contained within an artifact and container images? So we actually store our binaries as a checksum-based storage. That means that when you upload a binary into Artifactory, it's a Docker image, jar file, WAR file, whatever you do, we tear it apart, we catalog that as metadata, and then we store the binary as a SHA-256, and then the binary data is actually represented as part of the actual object itself in the database, which means we never duplicate binaries, number one. Number two, you also know the scope, right? So you know the reach of these binaries. And then on top of that, you can add additional metadata. So all those pieces and components, we extract it out with our algorithm, and then we store it appropriately in the metadata and as a whole. And it says, does X-Ray support native production for dependency confusion? Prevent attacks from remote repositories if they match package URL or something uploaded. You can write rules using the include patterns, exclude patterns to do that. There's all that materials. Actually, there's a blog on it online. And it says build info from TC, JFrog TC, I'm assuming Team City, doesn't give us detailed information as in shown in the demo. That sounds like it might be an implementation problem. Please set up, contact your sales rep and have it set up with one of our awesome engineers, like myself and my team, and we'll go ahead and we'll show you how. And then I see here that it says, are there plans to support package URL specification? I know Artifactory currently uses package URL format. We'll have to look into that. I don't have a direct answer to that right now.
So it's mentioned like this. DX and SPDX are in the planning, so it is in the roadmap. Right now, we have people that examining those formats and see how can this be integrated into the platform and what's the best way. So stay tuned, and we're gonna be able to project more solid information on the feature once it's gonna be ready. So I know I don't give like the immediate answer right now, but I do give you, I can tell you that I have active discussions internally about how to enable this in the platform and how to address this.
Excellent. So I'm going to skip the misconceptions, but basically all the questions here and answers here are no, right? They won't be able to get your roadmap. We don't have to disclose your source code. And even if you disclose the list of components, that's the thing is that it won't expose your intellectual property, because most of the time they're compiled sources and things like that. And in addition to that, it's like getting a list of ingredients without the instructions on how to use it. Then lastly, software bill of materials needs to work with the government. It's a list of your FOSS libraries that you can use in the software you produce. It lets you know how, what, and when it was made. It gives you auditability and traceability and potential threat metrics. And on top of that, the big thing is security and compliance, right? Are the big components behind this. And then I'll let Asaf take us out. So we learned something, didn't we? I hope we did. I hope you guys enjoyed this. But Asaf, take us out, buddy.
Sure. So I want to thank you again for being in the session, and I think it was very I hope it was interesting for all of you. So we got a chance to learn about the attacks. We got a chance to learn about what are the threats. And essentially, we hope right now that you have enough knowledge to protect yourself and your company. And don't lose hope, because it is a winnable battle that you can win. So as mentioned, you can implement runtime protection, I would say, against those typo squatting and dependency confusion attacks. And you can use X-ray as well to generate SBOM. Now you know exactly what is SBOM, what is the benefits of SBOM. And also don't forget about the best practices on how to have signed pipelines and have the zero trust approach of building secure binaries, because eventually you have the responsibility of delivering your software, and you want to make sure that this software is secured, sealed, and have the best practices in place. So we hope it was interesting for you. And if there are any follow-up questions, feel free to email to your JFrog representative or to us. We'll be more than happy to support and help you. And I want to thank you everyone again.
Excellent. Well, thank you, everybody. Asaf, absolute pleasure. Our first time doing this together. I am super excited. Thank you for all your effort on this and time. And you know what, guys, thank you so much for taking time out of your day to attend this. I hope this has been fruitful for you. And look forward to seeing you in the verse. Have a wonderful day. Be safe, everybody, and protect your company. All right.
Thank you all. Thank you, Bill.
Thank you. I think we have to wait for